Okay, here I'm gonna record how this demo is run and how it's designed. As you can see, I've already drafted a README file over here, which is a very brief introduction how I designed this simulation system and how it's different from the real network. And before we go through the this application, let's have a quick look at the slides which I offer over here. In order to simulate a network, I have to simulate these three objects or three elements over here: routers, hosts, and of course interfaces. And here I let a router host for interfaces which represent network interface cards, and also attached a host. And a host holds a window chart represent data source and a destination, and which can send and receive message or a data package. And of course, it will hold a interface over here to connect the hosts. And for a host, for an interface, it holds IP address and MAC address. Also holds different features over there, and you can refer the detail from the codes. I've already created a topology, network topology like this one, and with this simulating system. In fact, actually, you can create any small scale network topology in this application, because this application is configurable, and I can show you how to do that. Okay, let's run the application. Okay, before we run the application, you have to install these three libraries. And for the Ubuntu or Linux, you also need to install this Python GUI. Since Windows is no needed, actually I developed this application in my Windows laptop, but I have to record this demo because my on top of Ubuntu, because my laptop has some damage and returned to IT department to fix. Alright, and anyway, this three library is mandatory to run this application. And once we have this three library, and then we can run the this command on the command line. Of course, you have to need to install Python. Right, let's run. I'm gonna run in this IDE, but it's not necessary run in an IDE. Right. Okay. Once we run the main Python files, then we got this text menu over here. The first step we need to do is we need to create a routers and hosters. Here we just need put an integer number over here. Once every time when we create a routers, it will automatically create a host correspondingly. Here I'm gonna create 5 routers over here. And once we create these routers and the hosts, because I've already configured last time, and it will automatically load the configure from the configure files, so I don't have to need reconfigure this network topology anymore. And as we can see, here we have a lot of detail over here, like how to simulate a MAC address over here, and use queens to service or manipulate the data. Probably those queue more like a queues provided by SRX over here, like those facility and queens. Right. And once we create those objects, the RIP daemon thread is started to run and already to update the routing table. We can see from the lots of information from the logs. Here sorry. Right. It refresh very frequently because I set the refresh time is 2 seconds, every 2 seconds. In real networks, it might be 30 seconds, right? So the routing table will converge very quickly in this case because it's update very quick. As we can see, the routing table probably already converged. Alright, also the MAC table be updated because every time when the IP packets sent to the link layer is will encapsulated as a data frame and try to find MAC address from the MAC table. If not, they will send ARP and to update the MAC table. I've already completed those, implemented those mechanisms. You can check the code. Right, you can see the MAC table over here. Here I would like to mention here I just use one table to share ARP and MAC. In Cisco routers, seems they have separated as two tables. And now I'm not going to reconfigure this host and the router's address. In fact, we can configure those IP address, and those IP address are IP address version 4, not 6, and all the IP address will regard to class 3, class C, not class A and class B. As we can see, the route table, all the IP address net mask will be this one, so it will regard as class C. And of course, I can change a little bit. Then we can configure any type of IP address we want, but I will not do this anymore. Right. Once we create this topology, then we need to select the servers. We have to select some servers as a host as a servers because we will demonstrate how TCP work. TCP have servers and clients at the beginning. Of course, it will not really different once it's connected. Now, here in this case, in this topology, I will choose host 5 and host 4 as servers, and the rest of 3 hosts as clients. And then these 3 hosts can connect these servers, and once they connected, they can send a message to each other across to these routers, and of course they have to find the shortest path. And in this this demo, I just measure the shortest path as 2 measurement. One is shortest hops, another one is longest match for IP address in terms of binary. Alright, let's do that. Now 4 and 5 as servers. Now once we create, we select these 2 hosts as servers, we can open the chat window which attached to the hosts, as we mentioned earlier. Okay, now the 5 of the hosts window already created. Now let's use host. First, we can check the IP address over here. and then we try to use host 1 to connect server 5. Okay. Right. Let's connect. Now, once we hit this connection, it will go to three ways handshakes, and actually we can check from here. It will try to find the shortest path over here. Here we can see it choose to router 1, router 2, router 4, router 5, all the way to host 5. And it's interesting when host 5 send it back, it's go to a different path, router path, because but sometimes it will go to the same path because these two paths is exactly same hops over here. This router 1, router 2, router 4, router 5, or router 1, router 3, router 4, router 5. These are same. But it's already solved the routing loop. It's not going to this circle. It's not well stuck in this circle. Right. Now, once it's connected, then we can send a message to each other. Right. Let's send it. Hello. Right. Sorry. Hello, host 5. Now it sends the it will send TCP segment all the way to wrap to IP package and the frame, etc. And we can see more detail in the logs. It's too many for the ARP. Yes. Now let's check in the. Okay, host 5 already received the message, and of course it can send a message back. Let's just type something. Hello world. Alright. And also, let me give another example. Let's use host 2 to connect to host 4. Alright, let's try. It says occupied, and we can see the local address is the same, so which means it's actually host 2 already connected to server 4. Now let's send a message over there. Just type some crap over here. Now, host 4 already received the message over here, and I can send a message back again. Now let's disconnect it. The host 2 from host 4. Now host 3 can oh, of course you can check it. It's always find the shortest path over here. You can check. Now we can also now, because the server 2 already disconnected with server 4. Host 2 already disconnected server 4, so we can connect with server 4, the host 3. Now can send a message again. Right, that's it. And let's have a quick look at how it's working in the background on the. Right. Here's how I implemented this TCP socket over here. Here on the client side, we maintain two queens over here, acknowledge queen and finish queen, to listen this to this maintain these two queens to get acknowledge from these servers, and also to close the connection. And of course, acknowledge is always go around the send and receive stage, right? and I implement bind and listen in same function because it's just for the operating system to implement it to TCP. And of course, this TCP socket is a little bit different from the real socket. For example, in Linux kernel, they have acknowledge queen and a sync queen to maintain this connection also. Right, but it's quite similar now. And down to the IP and ARP level, once we have a TCP segment, the TCP segment will go to IP payload, and then IP will try to find the shortest path to send the package out. And of course, before when actually sent out, it will go to make as a encapsulated as a data frame, and of course the first step will go to find a MAC table or MAC address. If not, they will send a ARP request and update MAC table and send the data frame finally, the next hop finally. And here the dynamic routing protocol. Here I choose a simple protocol over here. Actually, I just read the some online article to learn how to implement it, and I use UDP to calculate this RIP package, and they send the neighbor routers which connected and their tables, and update them their route table, and I choose use horizontal split to avoid routing loop, and of course delete expired entries and update their table, etc. There are many details down there, but just one thing I want to mention. I didn't wrap a UDP socket because here in my UDP is just for send RIP package across to the network to update the route table. Okay. I think from the let's have a go quickly through the code a little bit. Once we hit the connect, and we go to this target this function and build create a socket and build a connection, and the connection will go do 3 handshake over here. You can see sorry, initialize. Oh, sorry, I should go to this class. Right, let's go to connection, the connection, and then go through. You can see we can set the and go to the 3-way handshakes over here. And I think I've already implemented most of the details from this those kind of socket and to the protocols. As you can see here, the TCP segment. It's a real TCP segment. We can actually send this to a TCP and API to send a raw TCP segment to other real network. Same thing for the IP package and ARP and UDP, etc. And for the low level, I tried to implement it simulate as close to the real network as possible. For example, when I simulated a host, we have an interface, and I use for 48-bit MAC address, and will transfer as a as a as a MAC address format. And actually, this API also wrap real MAC address as it is, right? And okay, I think I, I've already I've already posted my code on the GitHub over here. So I also will send this link to you, right? Thank you.